presentation is about the structure of aluminum. The main aluminum is oxide. It takes place in two stages oxide, silicon dioxide, titanium 4 oxide, iron 2 oxide, and iron 3 oxide, and sand. Aluminum oxide and silicon oxide dissolve in the alkali. So these are the equations of this is aluminum oxide plus silicon plus two hydroxide, which is aqueous, plus 3 hydroxide, which is rich.
Okay, as for the equation, you don't need to read the equation. Someone else in your group should write the equation somewhere there because we need to proceed with the explanation.
Have the base iron 3 oxide and the titanium oxide does not dissolve and are filtrated off as residues. The filtrate is transferred to a precipitation tank where it is seeded using pure aluminum hydroxide or low-grade carbon dioxide through the filtrate, which results into the precipitating aluminum hydroxide. Here having aluminum hydroxide is repeated off and strongly heated at 1,000 Celsius, degrees Celsius to form aluminum oxide. Which is aluminum.
Take one.
We are having the reduction of aluminum oxide by electrolysis. Since the melting point of aluminum oxide is high, Cryolite is added to low melting point of alumina. Alumina is dissolved in molten cryolite and electrolyte between graphite and electrolyte at 9,000 degrees Celsius. Low voltage and high current density. Aluminium is discharged at the cathode where it is stopped off, where it is stopped off. The oxide ion is discharged at the anode, forming oxygen gas. It gains 2 electrons.
Okay, that's good. Let's have another person to attack. Please.
Oh.
Attack quickly. Don't wait to be choosing. Okay, I'm going to choose now. Gertrude, attack! Tell us about the risk. Anyone risk, well explained, and its mitigation. We can't hear what you are saying. Let's give space so that we see what you are showing us. You are not showing yourselves, you are showing the class. Yes, so you should be facing us.
Some of the mitigations we have Proper maintenance of fire outbreak since the solution forms oxygen gas.
Come again.
Poor maintenance of proper maintenance of fire outbreak since the solution forms oxygen gas.
We are not understanding. We're telling us proper maintenance and gain fire outbreaks. Explain that properly. Or you can use other words to tell us. Because we are not BA. Another person in the group can tell us. Numbers tell us. A risk mitigation. First tell us the risk, then you give us a solution. What's the risk?
The risk is fire outbreak. Now, the mitigation is through providing fire extinguishers around the center, since the solution forms oxygen gas.
Do fire extinguishers prevent fire outbreak?
Yes. In case of fire outbreak, it stops.
The fire extinguisher does not prevent, but you use it after the fire has broken out. So, what is the exact risk and mitigation?
The risk is fire outbreak. The mitigation is through providing fire extinguishers around the center.
Tell us, what can we do to prevent fire from breaking out?
From breaking out? Through
another person in the group, help her, because we discussed the question together, discussed the assignments together.
In case of a fire outbreak, installing fire extinguishers around the center which stop burning.
Yes, the sodium hydroxide that is used in the extraction of aluminium in the concentration of the ore is highly corrosive. When it spills on your skin, it will cause skin burns. Yes? So how can we prevent skin burns? Personal protective equipment, like the safety gloves. Take us through the social benefit. Well explained and its impact on your life.
social benefits. Aluminium can help us to make the medicine.
Which medicine?
To medicine.
Which medicine?
Can be used to make things.
Can be used to make? Which one? Can be used to make what?
Helicopters.
How are airplanes and helicopters important to you? Tell us.
For transport.
Easing transport. Okay. Easing what? Transport. Why do we use aluminium for making aeroplanes? Because it is. Why don't we use concrete? Because concrete for making cement and use cement and lime for making aeroplanes. Can't we do that? Because concrete is also hard.
Aluminium is
Durable.
now with that. When it is used, yeah, it is durable.
It's durable. Concrete is also durable. Can't we use that for making an aeroplane? Why can't we use concrete but we choose aluminium?
No, Master, it's durable. Hence hoping that airplane or helicopter for easy flying.
She has the answer, but she has no words to say the answer. Who has the words to tell her the answer? Eric, Charles? This light has a low density. That's why it can be used to make plane bodies. Very good. Any questions for them? Yes, please.
According to the first paragraph, you say that it takes place in 2 stages, and the one is mentioned there. And the first paragraph says that the main aluminium is bauxite. I've never heard of that particular so it will explain the meaning of bauxite. So I believe you may know as okay, so that is
okay. He wants to know what is bauxite, what's the composition of bauxite, and a brief outline of the 2 stages, stage 1, stage 2. Who can do that quickly? We are not only asking their group, but the question is going to the whole class because we've been paying attention. We've been paying attention. You can give us an answer? What is bauxite?
So bauxite is the first
Okay, bauxite is the ore or the raw material from which you can extract aluminium. So what is it? What is its chemical composition? That's what he wants to know.
chemical composition. Let's go ahead. Let's
Search to recall. What's the composition of bauxite? You've been paying attention. Kisabomu. What's the composition of bauxite? You look at open where you wrote the ores, the different ores from which you can extract metals. You have your books. That information is already in your book. What's the composition? You go and write for us the formula of bauxite. Go and write for us there. So which compound is that? Can you read that compound? Which compound is that?
Aluminium oxide.
Before the dot. Before the dot.
Aluminium
Which
oxide.
compound is that?
Aluminium oxide.
It is aluminium what?
Oxide.
Oxide. Dot 2 moles of water of crystallization. Okay. So that is hydrated aluminium oxide. The composition of bauxite. Outline for us the 2 stages. Stage 1, stage 2. Give us a brief outline. Stage 1, you mentioned it. This first stage of crushing the ore into fine particles and feeding that crushed ore into a tank or a concentration tank containing sodium hydroxide solution. that stage is the concentration stage. Stage 1 is concentration stage. You write for us. Concentration, write for us there. 1, concentration stage. Stage 2, extraction by electrolysis. Stage 2 is what? Is what? Speak like people who had something in the morning. Stage 2 is extraction by what? Electrolysis. Those are the 2 stages. Question 2. Yes, your hand was up.
I have 2 questions.
2 questions.
The first question is the process involved the use of silicon. Is it dioxide? Why? Why is silicon dioxide?
Why do you use silicon dioxide? This is his question. Why do you use silicon dioxide? Have you used it anywhere?
Abbas, pardon your question.
Why do you use silicon dioxide in the process?
Because silicon dioxide, because it dissolves in the alkali.
Now, though silicon dioxide is not used to extract aluminium, but silicon dioxide is an impurity. Is a what? It's a what?
Impurity.
An impurity. These ores are mined from underground. And on the ground you'll have sand, you'll have particles of rocks containing titanium oxide, you'll have particles of rocks containing iron 2 oxide and iron 3 oxide. All those are what? Impurities. But during extraction, we need to purify. Okay? So concentration of the ore is where you remove all the other impurities. For example, titanium oxide, silicon dioxide, aluminium, rather iron 2 and iron 3 oxide. Is that okay? Which other question you had to?
On stage 2, the extraction by electrolysis, there is a use of the graphite as the electrolyte. Why?
Why do we use what?
Graphite as electrolyte instead of carbon electrodes?
Why do you use graphite instead of carbon?
Where you see your graphite, you are using
Who can answer that quickly? Any other person from the class, you answer that quickly. Let's not leave the question pending, yes? Graphite is less reactive. Graphite is an allotrope of carbon. Okay? So you cannot say graphite or carbon. It is an allotrope of carbon, right? So graphite contains carbon. Yeah? The question that I would expect you to ask is, why do you add cryolite, molten cryolite, during electrolysis of aluminium oxide? Why do you add molten cryolite? Yes?
Because
It's because what?
it has a high melting point.
Aluminium oxide has a high melting point. Aluminium is a metal. Oxygen is a non-metal. A compound formed between a metal and a non-metal is an ionic compound. It's an ionic what? Compound. And one of the properties of ionic compounds, we say that they have very high melting points. So you must add molten cryolite to lower the melting point of aluminium. Yes. Question? Why do you choose electrolysis, not any other method for the extraction of aluminium? Good question. Good question. Good question. Yes. Is there anyone who has an answer?
On that.
So we need to make it.
Master.
Let's hear from the class. Yes.
It's because electrolysis is used in the extraction of highly reactive
metals. In the reactivity series, that's very good. In the reactivity series, aluminium is above carbon in the reactivity series. So those elements that are above carbon in the reactivity series are extracted by which process? Electrolysis. Later on we shall see how other methods that can be used to extract other elements like copper. Those ones of copper will tell us about that more. Those ones of iron will also discuss to us. Is that okay? Are the questions over? Let's clap for them. Yes, as they go to sit. So you are going to pin your charts. Now, next group.